So, in the previous video, we have created or designed this ERD and we come up with those set of tables. Right now, in this video, we are going to create the models project, which is basically a .NET Standard project, class library, and create the models that will represent this database schema, or let's say all the business models. Then we will create the application DB context of the entity framework core. So in this case, we are done from the data layer that's going to initialize the database for us and this stuff. So here in the Visual Studio, I have an empty solution called TicketsBasket. Now within it, I will create a set of projects, and those projects, they are going to be separated into clients and server. So it's the server side is going to be consists of multiple projects. For example, the .NET Core API project, the models, the class library, the repositories, the services, and other infrastructure services like the storage service and something like this. So basically, put every part of your project in a separated of your solution, a separated project. So this is going to simplify the development process and will simplify also the deployment, because your project we're going to based on multiple DLLs, not only on the main one. If you put everything within the ASP.NET Core web application, yeah, it's going to be a little bit hard to maintain and manage all the code in one place. So to get started, I will create a new project, but before that, let me create a new folder. I will call it server. So here, all the projects related to the server side will be placed here. Then right-click on the server, then click on New Project, Add New Project. I will choose Class Library, .NET Standard, click Next. I will call it TicketsBasket.models. Okay, here we have this empty class. Let's remove it. That's great. Right now, we have this project, and here we will have the domain models, or the classes that are related to the business process for our application, which are basically those we have created here that we're going to represent this table, like event, user profile class, event tag, event image, and so on. And we will have the DB context. So I will create a new folder here just to stay organized as much as possible. I will call it domain. So basically this is going to contain the domain classes, and within it I will click on add a new class. Okay, and I will call this one record. Record, if I go back to the ERD, as you can see, each table contains an ID, and all the IDs are varchar, or in C# they are strings, and their data is going to be initialized when we create a new object with a new global unique identifier, or GUID. So, and another thing, that this database is very simple, which is basically like here we have only the ID shared between all those entities. But in the real world application, probably you will have the ID, and you will have the user ID that created this entity or modified it, the user that modified it, and the date of creation, the date of modification. So always you have at least those. So instead of repeating those with initializing their values in each entity, we can create a base class called record and put those shared within it, and then other entities going to inherit from this one. So I will initialize this one with only string ID for now. And basically it's a key. Yeah, we forget to install the library of the entity framework. So it's going to be install package Microsoft.entity framework core.sql server. Okay, so right now the library is ready. Let's add the system.component model.data annotations to add those to here. So right now, this key attribute means that this one is the primary key, and let's create a default constructor, but within it I will initialize the ID with GUID.new.toString. Basically, if you're not familiar with this one, it's a global unique identifier. It's a string with a 40 characters length, contains alphanumerical characters. It's randomly, and because it's too long, like 40 characters is too much, and the huge variety of characters it uses between the numbers and letters, this is going to give you a very, very low percentage of, or low probability of conflicting those IDs, even across the systems, not only across your data in the database. So it's highly recommended to use it as an ID. So I will close this one right now and create another class. Basically, I will call it user profile. Okay, mark it as public and inherits from record. So right now it has an ID. Let's add other properties. First name, we have last name, we have email, then country, city, and we have also a pool is organizer, and we have date time created on. Okay, those are all the properties of the user profile. Let's add the constraints of this. Let's say that this one is required, it's not null, and string length is going to be 25, like this, for email, for the country, the city, and is organizer and date time created on is by default. They are required. So, and here in the constructor I will initialize created on, I will set it to datetime.utc now. Okay, so in this case, whenever you create a new object of this is going to be initialized, and the ID as well, so you have to only care about those properties. Great. Another thing to mention here is, as you can see, I have used UTC now and not now, which basically this is the universal time coordinated, and because this one is not the local time of the user or the local time where our application is running. Basically, when you develop any application, always you have to know that your customers is located everywhere. So this application, especially because if it's a web app, it's accessed by multiple people from multiple geolocations. So in this case, the time is a very big issue here. For example, if our application is located in the west coast of the USA, which is basically 10 hours difference from my time zone here in Beirut. So if I add a new record, create a new user profile, and right now the time, as you can see, is 11 p.m., which is basically in San Francisco it's going to be about 2 p.m. or maybe 1 p.m. So this means that if I use datetime.now, then now it's going to be on the server, so it's going to be 1 p.m. So I add the object right now, 11 p.m. in my time, but it's going to be stored in the database at 1 p.m. or this means that it's stored in the past. So this is a very critical issue. So the best way to solve it is to store all the time within your system in the UTC, which is basically the universal time across the world. And whenever a user accesses the data, you have to fetch the time zone of that user and convert the time from the UTC to the user's to the client's time zone, then retrieve that with let's say for the suitable time zone, for example. Okay, we will cover this point within this project. So for now, the first step we should take is to store all the data in the UTC zone. Okay, so basically that's great. This is the user profile. Right now I will create another class, which is the event, and again it should inherit from record. Let's see what we have here. Okay, first we have title, we have description, we have cover image URL, we have location, integer tickets count, the maximum number of the tickets, and we have the number of views of the event, we have the user profile ID and the price. So here we have the price, and we have the relationship with the user profile. We will leave all the relationship to the end after we create all the classes, and we have the date time created on. We can also add the created on to the record, but we don't have it on all the tables or on the classes, so I will leave it on the level of each entity. datetime.utc now. That's great. So again, let's add all of the checks here. 80. Subscription. The cover image, it's going to be required. If the user doesn't choose a cover image for the event, we will set a default one, but anyway, it's going to be required. The location also is going to be required. And we have the price. Okay, those are integers. Yeah, the price. Here in Entity Framework Core, we have to mention that the decimal is going to while the Entity Framework tries to create the database, going to be conflicted a little bit, because decimal, you have to set the precision of the decimal, and to do so we can do it using the attribute column, and you can set the type name equals to decimal 18 and 2 decimals. Okay, so in this case, this is going to remove the conflict of the precision, and the process of creating the database will go smoothly. So at the end, we will add the relationship between the tables. Let's complete with other entities. We have event tag. Make sure that the name of the classes are single, like it's called event tag, not tags, but the tables, they are going to be tags. So here we have only name and the relationship with the event, required string length 40. Okay, so that's great. Let's move on. Event image, string image URL, string length like that. We have the thumb URL, thumbnail, okay. And this one is just going to be string length. Maybe we don't have a thumb URL at the beginning. And we have the relationship with the event. Let's complete. Class. We have ticket, record. We'll have the barcode, we'll generate it, and we will have the discount, but this one could be nullable because maybe there is no discount applied. And we have the final price, decimal, final price after the discount, if there is any, or it's going to be the same for the ticket price here in the event, defined on the level of the event. So we will have the place. We have the date time created on. We have as well, just the relationship. There is also another property that you have mentioned in the comments section. Thank you so much for your interaction with the previous videos about to mention that if the price of this ticket is paid or not, and add comments to the events. I will consider all of this, and basically I'm working currently on a group on my website related to this as a discussion, so we can work on all this extra materials on the project, but outside the videos, because the schedule of the videos has been already set, and those are going to increase the number of the videos and break the schedule. But I'm going to follow with you with those properties and the other new challenges outside of the schedule via the discussions and the GitHub and other blog posts that's going to be available from the beginning of the next week. I will share the link of that discussion group within the description of each video. So thank you so much for your interaction, and I hope you are enjoying this course. So let's move right now to the wish list. Basically, it's better if we call it wishlist item, because it's going to represent only one item, or event wishlist. Wishlist event, We will have just created on. And the relationship with events and the user profile. We have as well the like. Public. We don't have liked on, we have liked on. You can use created on, but it's the same. Let's follow the same naming we have defined in the previous video. Okay, so we have also the relationship, and at the end we have job application, object string, we have the position, we have description, CV URL, we have status, and the relationship. But basically for the status, we are not going to set it as a string. I'm going to create a new enum here, enumeration. I will call it job application status. It will has multiple values. The first one will be pending equals 0. We have reviewed or reviewing 1, rejected 2, and let's add another one, which is, for example, accepted 3. So we have those set of predefined value. That is going to be better for querying and retrieving the data, and this is going to be translated into an integer within the database. Only one disadvantage for using enums in the database that you have to be careful with the numbering. By default, as you know, if you don't set a number for the enum, it's going to be starts from 0, 1, 2, 3, but it's better to define your own number because, for example, you have right now already a data exists and you have about 200 job application that has been accepted and the status is 3. And in the future, you came up with a new value and by mistake, you set it here at the beginning. So you put it, for example, interviewing as an example. So if you don't set the numbers, this is going to be number 0, 1, 2, 3, and this one is going to be 4. So the querying system of your application will be somehow destroyed, or you will retrieve data that's not related to what actually you want. So make sure always when you create enums, to use within the database to give them numbers by yourself, not to use the normal numbering system used by the enums in C#. So we have the status, and the last thing that we have is the relationship between these data. So I will go to the top. First, let's start with the first one, which is basically the user profile and events. Here we have each user profile can create multiple events. So it will have a list of events, call it events. And I have used here the virtual keyword because we will use the lazy loading. Whenever we retrieve an user profile, the events will be populated instead of making multiple calls to the database to retrieve each events or each objects related to another one. And within the event, at the top, as I've said, user profile has multiple events, so it's going to be a list, and each event will be related to only one owner. So it's going to be like this: virtual user profile, I'll call it user profile, and this is going to be the foreign key, user profile ID. By convention, because here we are using user profile is the name of the class, and this one called the navigation property, and here we are calling it the same plus ID, so it will know that this one is a foreign key for the user profile. But if the name is different, and we will see this in the job application, here we have application user ID and organizer ID, we have to set a foreign key attribute. So in this case, the entity framework will know that, hey, this is a foreign key. But for now, it's just like this. That's great. Now, for each event, we'll have multiple tags. So again, we'll have list of event tags, like that, or you can call them tags alone. It's going to be enough as well. And here the same thing. For each tag, it's going to be available for only one event. Create the navigation property, and create the foreign key, and that's it. It's going to be the same, the same for the image. Each image is going to be related for one event, and the event will have multiple images. Great. Right now for the ticket, again, this one is going to be many-to-many between the user profile and the event. So each event will have multiple tickets sold, like this one, tickets, and the user profile also will have a list of tickets. Okay, so within the ticket, we will have a reference for the event. And you will have reference for the user profile. Like, who bought this ticket? And yeah, I think that here, sorry, but we forgot all the checks. Here the barcode is going to be 10 only, decimal, here we have only column. Type name equals to decimal, and yeah, just so this for the ticket, and for the event as well, it's going to be exactly the same. The wishlist event is going to be, as you can see here, it has user profile ID and event ID. So we'll add them here, and again for the event we'll copy this one like tickets and say wishlist events, and let's copy it also for likes, and I will copy those and paste them also here on the level of the user profile. Okay, so tickets, we can from here copy those 2 likes as well. So we are done from it, and we have the last one, which is job application. This one will contain something new, because as you can see, the user profile, the normal user account will have multiple job applications that he applies for, and the organizer will have set of job applications that he receives from normal users. So basically, here we will have, in the level of the user profile, you will have a list, public virtual list of job application, this one called sent applications. So this is going to be sent by normal user, and there's going to be another list also of job application, but this is going to be the received applications. Received applications. Okay, so the user profile has many-to-many relationship with itself by the job application. So if we go to the job application, this one is going to have the sent by user and the received by user. So we will have virtual user profile. We will call this one applied user, and string applied user ID. But this one right now, the entity framework cannot detect that, hey, this is a foreign key for the user profile, because the name here is different, called applied user. What you have to do is to use the property called attribute called foreign key, and we can say that this is a foreign key for the applied user navigation property. Okay, so right now this one is going to be a foreign key for the user profile, and we will have another one called organizer that basically will receive this job application, and here we'll type organizer ID. This is going to be foreign key but for the organizer, and here we go. This is basically all the relationships and the property, the attributes we have. The last thing that we have to do is to move each one for a separated class. Move to, click on the tags, move to, and here also move to ticket. Okay, that's great, and I will put this with the job application class in the same file. So that's it. This is basically all the models that we need for our project. Now the next step is to create the application DB context and just set some configuration for the relationship, like the cascading and what's going to happen when we delete a specific record or a parent record, what's going to happen for the data related to that. And we will do all of these steps in the next video. So thank you so much for watching, and if you have any question, as always, I will try to respond as much as I can, as soon as I can, sorry. And if you can put them in the comment section. Thank you so much, and see you in the next video.